So why does this happen? Okay, because can they fully lose and gain? No, because they're not from the left and the what? If they are from the left and the right, or from the middle and the right, then one of them will definitely what? Lose, and one of them will gain. Well, guess what? Now they are both from the right. So none of them is a strong loser. Both of them are kind of what? Strong gainers. So they don't want to lose. So what they end up do is what? Is they end up, so non-metals, the ones on the right, have an almost full valence shell. What does almost full mean? They could have 7 or 6 or what? Or 5, okay? Almost full, which means what? It's not too far from them to what? To become full. They are almost full, okay? So what do? They share. They never fully give to each other. No, they get close enough, like this. Remember from yesterday? Like this. They need to come close enough to each other for them to what? For them to share, okay? That's the thing about coming very close together. It seems like each one gained what it needed to gain, but it didn't, because it needed the other one to be very close, okay? So nonmetals form covalent bonds with one another due to, or what does due to mean? Because of the what? The sharing of valence electrons. You only touch the what? That's why they call it what? Valence means you make covalent. Co means sharing. Valent means you're sharing the valence ones. You never share the full circle. Sorry, you never share the first circle. No, it's already there. It's done. You share the outside circle. Okay? Since they both want to gain, they can't just steal it. Okay? It's impossible. So they end up what? Just saying, you know what? Let's work this together. Let's what? Just get close enough that we can seem like we gained, but we didn't because we're just sharing. Okay? So shared electrons spend time orbiting both atoms. We just put them here. Why? Just to show you that, you know what? This is the region of sharing. This is the intermediate, or the, not intermediate, middle region. And then what? They kind of connect the two together, okay? They just form a connection like that, okay? Yes, the electrons attracted to both of them. The resulting thing is called a what? Who can read that word? Break it down. It's actually 2 words, but it's said so quickly, it's like one. What's that word? Molecule, not cool, cool. Molecule. What's up? Yeah. Okay. Molecule. This whole thing is a what? Is a molecule. What about each one of these things? Oh, each one of these things is just an atom. 2 atoms make a what? 2 atoms together make a what? Connect to make a what? A molecule. Okay. What about 3 atoms? Yeah, they just make a bigger molecule, and so on and so forth. Yes. So these two circles are exactly that. Yes, yes. But okay, but wait. Don't copy it now. Let me just finish this. I'll post it tonight, okay? By the way, I think this is Mr. Check notes from last year. He's using X's. That's fine. I used what yesterday? Do you remember? I didn't use X's. I mean, I could, but I chose dots and diamonds, like, you know, like these squares that are tilted. Okay, yo, what's up? What's up? Sure, go ahead. Okay, all right. So I think we covered that one. Okay, all right. What molecule is this? Very famous. You can't actually be alive without it. What is that? H2O. 2 H's and O. H2O. Okay. By the way, here's a question. Why can't we say? Me? Why can't we say? So it's H2O. Why can't we say OH2? This is by the way, this is a question I'm going to explain now why we can't. But does anyone know why we can't say, the water is OH2? I mean, technically, is that the same thing? Technically. Is H2O the same as saying OH2? What do you think? Yeah, well, think about it. H2O means how many hydrogens and how many oxygens? What if you say OH2? It's the same thing. You're just starting with the what? With the oxygen, and you're finishing with the what? With the 2 hydrogen. Do you see what I mean? I'm still saying that we have 1 oxygen and 2 hydrogen, but you will never hear anyone, no matter if they're in grade 9 science, 10, 11, 12, or actually a chemistry teacher or a chemistry professor, say OH2. You know why? Because again, the first one has to be like the positive thing, and the second one has to be like the what? Yeah, kind of like ionic. Okay? What? Yes, what's up? No, no, no. So, okay, let me just see. What do we have here? So we have this, and now we are doing. Uh, no, no, no. You don't have to sketch it, but it will be posted, so you can always, have access to it in the notes. Okay. So there are three types of covalent bonds. In a single bond, how many electrons are shared? In a double bond, how many electrons are shared from each one? In a triple bond, how many electrons are still shared from each one? Can you ever share 4 pairs of electrons from each one? No. It's either 1 or 2 or maximum what? Maximum 3. There is no. So what's the name for the first bond? Single. What's more than single? Double. What's more than double? Does anyone know what comes after triple? Quadruple. Exactly. That would be how many bonds? 4 bonds. That never exists. In all of chemistry, the maximum number of what? Of bonds between molecules is up to what? 3 only. You can make a triple bond. There is no such thing as a quadruple bond. Okay? So go ahead and write this down. So in a single one, you create a double. Sorry, if you just share 1, you create a single. If you share 2, you create a double. If you share 3, you create a triple. You will never be sharing 4. Okay? So single is 1 electron shared, double is 2 electrons shared, triple is 3 electrons shared. Nothing more exists as far as I know. Okay? And as far as many chemistry people know, nothing more exists. Okay? Triple is the maximum. Triple is the maximum. Okay? All right. Are we good so far? Again, very basic copying here. Okay. What's the next slide? That's the H2O. Okay, everyone, how many people agree that this is H2O? Just, okay. Will you remember what we call this one? How many O's do you see? How many oxygen atoms do you see? 1 or 2? So what do you need to call this? O or O2? Because remember, whenever you mention the name of what? Of a molecule, you have to also what? Do the proper numbers of what? Of everything in it. How many O's do you see connected together? So this is what? O2. Do you remember why I told you about this? Oxygen what? Everyone, whenever you breathe oxygen, right now, you're breathing without you knowing it, obviously, because it's just a process that your body does. I told you that oxygen flies in the air. It never flies as how many? It always flies as, because it naturally wants to have a what? Yeah, it can't just exist on its own, because on its own, it doesn't have an almost full. But together, they seem each one to have a what? Again, on their own, everyone, on their own, each one is almost full. How about together? They are not almost full. They are actually what? Full. They share, and that's what makes them full. Do you see what I mean? Almost full. They don't want to be almost full. They want to be what? Full. The only way to do it is to what? Connect together. And now they're what? Stable and good and happy. Okay? Molecules are happy when they are what? When they are what? They are not happy when they're what? They need to be full to exist with no problems, okay? Not to break apart, just stays together, okay? All right. So this is OH, sorry, I made the mistake. H2O, and then O2. Is there another one? Huh, what is this one too? What's N from the periodic table? What's the element N? No, no, no. Okay, who said neutron? Neutrons are small n, remember? Nitrogen. By the way, always easy. Oxygen, and the neighbor is nitrogen. They are nitrogen. No problem. Nitrogen. How many nitrogens do you see? 2. So again, if you're not if you are actually right now, there's some nitrogen in the air. Very small, but there is still some. And the good thing about nitrogen, if you breathe it, it does not do anything to your body. It doesn't react. You breathe it, and you breathe it out. It does not. Oxygen is different. Oxygen, your body uses it. Can you ever live without oxygen? No way. You will suffocate, okay? You will run out of air. Nitrogen, if this room is completely cleaned of nitrogen, you will not feel a thing. You just need oxygen, some water vapor, like some humidity in the air. Otherwise, your lungs would get so dry. I don't think you really care much about nitrogen, dust, all of that stuff. But still, it's in the air. And again, do you remember? Okay, what living organisms need nitrogen? We need it. We get it from food. But what elements? Huh? Plants. Trees cannot live without what? Trees cannot live without what? Nitrogen in the soil. Like that plant right there. When Mr. Chick is planting it, he had to make sure that the soil inside. He had to put some potting soil inside, like from the big bag from like any store, and it had to have some nitrogen in it. If he doesn't put nitrogen, it will completely go away. Yes. Your quiz? It's okay. You can do it at home because it's online. Yeah. Okay. Okay. So nitrogen. So that means what? Where is the nitrogen that I'm breathing right now coming from? The what? The plants outside. The plants outside are releasing some oxygen. Also, the soil itself is getting some of the nitrogen in the soil is mixing with the air. That's mostly where it comes from. Okay. All right. So this. Oh. So what's the name of this molecule? Is it just N or N2? O2, N2, H2O, and so on and so forth. Okay, you're getting the idea. What's up? This is nitrogen. Two nitrogens stuck together. Now here's a question for you, everyone. Can you count how many electrons are in between them? By the way, the dots are electrons and the X's are electrons. They just come from different ones. How many people are actually counting 6? I am, yeah, and Zainab and everyone. 1, 2, 3 from this one, and what? 1, 2, 3 from that one. So how many electrons in total are shared? 6. But how many is coming from each one? 3 and 3. So would this be a single bond, a double bond, or a triple bond? Exactly. When you know it's 3, you know it's a what? It's what we call a triple bond. Triple bond. Okay. Hold on 1 second, Robert, before you go. How about this one? How many are being shared? But how many are coming from each one? 2 from this one and 2 from this one. So is this a single or a double bond? Double. How about this one? How many are being shared? Not in total, no, in each one. No. How many are being shared here? 2. But how many are coming from each one? 1. 1. This one used to be here, and this one used to belong here. So 1, 1. Okay? That's what. That's our H2O. That's the most important compound or molecule in the universe. Okay? Every living organism needs water. That's why whenever they go to a planet and they think, was there any life here like on Mars? They are actually now thinking that there was life on Mars. They didn't find water, but they found what? Some water ice crystals. It doesn't matter. At some point, H2O existed. And if H2O exists as either a solid, like ice in the freezer, or liquid, like in the water here, for example, or gas, like when you boil some water, that means living organisms definitely existed here at some point. Maybe not anymore, but there was at some point, okay? When water exists, life exists. It's like a biology principle. Okay, you can even talk to the biology teacher and they do the same thing, okay? Okay, so now let's talk about this one. Can someone read the first word? The second word is good. It's, yeah, what's up, sorry? Yeah, go ahead. And here's the pass. Right here. You got the whole pass, new one. Okay. The second word is molecule. Can someone read the first word? Again, break it down into 2 parts. Yes. Hold on a second. What's up? Yeah, go ahead. Raise your hand if you think you can break it down. Yes? Di. Di is one word. And what's the other word, Ethan? Diatomic. You don't have to say diatomic. You can just quickly say it. What? Diatomic. Diatomic. Let's say it together. Diatomic. You just like the word di and just say atomic. Diatomic. What does diatomic mean? Things that consist or things that are made up of how many? What does di mean? Di is another word like bi. Binary means two, and di also means what? Two. So diatomic means what? Molecules made up of how many things? Two of what? Keep reading. Two of the what? No, keep two of the same atom. It's not like oxygen and hydrogen or nitrogen and phosphorus. It has to be two of the what? Two of the what? Okay, question for you. Is this diatomic? Is it made up of two things? And are these two things looking exactly the same? Great. But what if someone says, but it's made of two? I can see two things connecting and sharing. Yeah, that's only one condition. What was the other condition that had to be there? They had to be the same. Do these look like the same element? No, they're not. So again, remember, yeah, this could be, for example, oxygen, and this could be, I don't know, like maybe carbon or something like that. Sorry, but you might say, but they're sharing. Yeah, I'm not saying they can't share. I'm not saying they can't share. I'm saying what? You cannot call them what? You cannot call them what? What word? In the new word? You cannot call them diatomic. Call them anything else. You just cannot call it diatomic. Can you call these diatomic? Okay, here's a question for you, everyone. What if I invent a molecule, three atoms of the same element? Is this diatomic or more than diatomic? Do you know what's three? Di is two. What's three? What does this look like? What shape does this look like from geometry, from math? Huh? Triangle. Tri in math means what? Three. So this is what? How many is this? Diatomic. What about now? Triatomic. You got it. Atomic, diatomic, triatomic. Done. Okay. Again, you can call it quadratomic or tetratomic. They have a couple of different names, okay? But we are not, I don't think in this course we're ever going to go beyond what? Diatomic. Yeah. If you take grade 11 chemistry and grade 12, you will get into triatomic and so on, okay? So diatomic molecule is any molecule with two conditions. It has to be two things, and they have to be the exact same thing stuck together. Sorry, stuck together like that. Yes. Let me just finish this one. Okay. What are the 7 common diatomics? There's only 7 that could exist in nature by themselves. Hold on. Here they are. What's the first one? Hydrogen. If you're breathing hydrogen, by the way, now, and it's coming into your nose as how many? How many? Hydrogen can only fly as 2. Okay, what else? Hold on, what's this one? Nitrogen, oxygen, and what's easy about the rest? They're all what? In the same family or in the same group. What's this one? Fluorine. Just change. Chlorine, bromine. This is the only one that sounds different at the end. You can't say iodine. That's what? No, not iodine. No. Iodide. So fluorine, not fluorine, fluorine. Chlorine, not chlorine. Bromine, not bromine. Last one is different. Iodine. It's the only one that's different. These are the only 7 that actually what? Can exist as what? As what? As what? That's why they call it the diatomic 7, like a superhero group. The diatomic 7. HOFBR Inc. It's easy to know where they are. Just make sure that you do these 4, right? Turn left and just do these 2. So, by the way, how many are these 2? Just sorry. How many are all of these? 1, 2, 3, 4, 5. But they need to be how many? 7. So you have to add 1. Which one do you add? You go all the way to the beginning of the periodic table, and it's just the what? Hydrogen. Oh, okay. You might say, what about other elements? What about helium? What about carbon? What about phosphorus? What about sulfur? What about aluminum, silicon, bismuth, indium? Nope. They never exist as what? They only exist as one and only one. The only ones they found that they exist in diatomic or flying like two connected together are these 7 only. Okay, so it's good. It's not like there's 100 of them. There's only 7, and they are near each other, right? It's not like you have to memorize, oh, one is here, one is here, one is here, one is here. No, 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 no. They're all neighbors. They're all perfect neighbors. That's their neighborhood. There's only one that lives completely in its own what? Spot. Hydrogen all the way to the left, all the way up. Because what's the atomic number of hydrogen? 1. It's the very first element. It's the one that just starts, and then you keep going down and to the right. Okay? All right. Okay. Drawing bonds. Let me see. Okay. You don't have to write anything for the first 3 lines. They're already given to you. So a single line. Okay, everyone, pencils down. How many of you have seen things like this before? Yeah, I mean, if you've done some science or some chemistry, you always see chemistry sketched like this. Okay? They always use lines. They always use lines. Guess what each line... Yes, what's up? 2 people out. Let's just wait until one of them comes back. What does it mean that they have a line? You might say, oh, nothing. They're just... Give me your hand. That's it. No, yeah. You might say that, oh, I'm one thing, you're one thing, and this is the line between us. Well, guess what that line is? That line is how many electrons? 2 electrons. Okay, take this electron. Everyone, he has his electron, I have mine. Are we now close or separate? Well, we need to connect. So what do? Before, I used to what? Lose mine, and you get, right? I lose, he what? Is that covalent or is that ionic? Come on, when I fully lose, when I'm like sodium or something, and he gains. That's what? That's ionic. I lost mine fully, and I'm happy because I lost mine. Apparently, my charge is 1 plus, and he's happy because his charge now is what? 1 minus. I lost 1, he gained 1. Well, guess what? Give me 1. Yep. That can't happen anymore. I can't lose to him, and you can't what? Throw it. You can't lose to me. What do we have to do? You bring yours, I bring mine, and what do? Extend your hand. Now, okay, everyone, what does it seem like? Okay, hold these 2. Hold them with one hand. Stay there. Okay, it seems that I have lost mine, right? I didn't lose it. I'm still close by. I still have it in my neighborhood, right? I'm just giving him a little bit of a... Sorry, not giving him. I'm just getting close to him so that he feels that he has how many? But I feel like I have how many? So it seems like I what? Seems like I what? No. It seems like I lost. It seems that he what? Gained. But no, I'm still close by. What does that mean? If I want to go away, I'm not just going to go away. No. I'm going to what? I'm going to take it with me. No, seriously. Always think of it this way. That's what sharing is. It seems like everyone is happy, and we are. But if I walk away, oh. Before, I give him, and just what? I have to go away. I have to fully go away from him, and then, but we still have a bond between us. Here now, no. I need to be what? Thank you. Close enough. Okay? So, what does that mean? This line here is actually how many electrons? 2. 1 from him, 1 from him. All right. How about this line? Also what? 2. 1 from where? 1 from where? 1 from him, 1 from him. How about this one? 1 from him, 1 from him. How about this one? 1 from him, 1 from him. Do you know, actually? Okay, carbon and hydrogen. By the way, how many carbons do you have? I'm going to tell you a very interesting thing about this one. How many carbons? 1. How many hydrogens?
4.
So can someone tell me what's the formula for this? Come on.
H4.
Okay, so you're going to say H4. Remember, you have to tell me the numbers of each thing. You said H4. How many C's?
1.
Okay, so you're saying H4C1. Technically, do we ever say the 1? So you have to say what?
Wait,
H4.
H2. What?
No. I'm asking now, what's the name of this? You're saying H4C. Everyone, you will never see anyone called H4C. It's actually the other way. C. No. Remember, there are no numbers in them. There are all numbers below, right? Like H2O. H, and the 2 is not next, it's under, right? So you have to say CH4. Because, okay, Zainab, if you said C4H, that means you have 4 C's and 1 H. Do you see what I mean? If you said C4H, that means you have 4 of the C's and 1 of the H, right? But you don't. You actually have the what? You have the what? The other way around. So you have to say what? C1H4. Make sense? Have you ever heard of methane? Where? What do you know about it? Methane gas. But, okay, by the way, this is a gas. I mean, you can make it liquid. You can make it solid. But most of the time, it's natural as a gas. Do you know anything besides that it's a gas? No. Everyone, you know what this is? Have you ever driven near a farm with cows and it smells really bad? That's it. Yeah.
I want these.
That's farting gas. Yes. Methane, especially with, for example, like cows and cattle. Yes, that's why it smells so bad, because they're constantly what? Producing methane. But guess what? You might think, well, that's a very, very, very stinky gas. Actually, this is one of the most important gases that also exists where? Under the earth, like not under, like underground. And it's actually a very important source of fuel. From methane, if they extract it, that's actually one of the things they're trying to actually start to make technology for. They don't always want to use gas, like for cars. They actually want to start converting what? Methane gas to what? To fuel. And there is so much of it under the ground, and in certain parts like farms, so much of it in the air. They're trying to actually learn the chemistry of it to actually produce what? Methane gas fuel. Okay? But that's it. Yeah. This is why a farm smells so bad. Because cows, especially cows, are notoriously known and well known for what? Producing a lot of what? Of methane gas. I mean, come on. They're eating grass all day. They're eating grass all day. Even when you eat a lot of vegetables. By the way, are vegetables good for you? They are very good. But if you eat too much, what happens to you? You feel what? Not fat, you feel bloated. Because vegetables have a lot of fiber in them. And fiber what? Fiber takes time to be digested, like broken down in your body. So if you have a lot of fiber, yeah, that's good for you, because that's going to make you healthy and go to the bathroom well. But the problem is, if you do too much, there's so much fiber, it fills you up, and it takes time to be what? Digested. In the time it's being digested, you're producing a lot of methane gas. That's why eating vegetables is good. If you eat too much, you're not going to get sick. It doesn't make you sick. It just makes you uncomfortable because you're full of gas, because they take time to what? To be broken down. Just know this. Yes. Go ahead. Yes. Okay. Now. Okay. Everyone, question for you. How many lines do you see here? No, right here. Come on, it's not a trick question. No. Just how many lines? How many lines do you see here? One line, yeah. But one line means how many electrons being shared? 2. So if you want to take out this line, you have to sketch a dot here and a dot here. Okay, how many lines here? No, how many lines? I love the fact that you're starting to what? To understand how lines and electrons are what? Are related. How many lines here? 1, which means how many electrons is it in real life? Okay. How many lines? Okay. Oh, thank you. Awesome. How many lines do we have here? 3. But each one of them is how many electrons? 2. 2, 2, 2. So it's 6. Okay. How about this one? How many lines here?
1,
Which is 2. How many lines here?
1,
Which is 2. How many lines here?
2.
Which is 2, 2, or 4. What about these ones? How come these are not given lines? 4 dots, 4 electrons. left free. What does that mean? They're not connected to anything. These two are what we call free electrons. Free electrons are electrons kept around the nitrogens, and they're not connecting to anyone. So let me show you. Pencils down. I mean, you're going to have it in the video. And so, yeah. Let me just sketch one and show you, okay? Because the idea is the same. Okay. All right, everyone. Dunya, which one of these should we sketch? Let's sketch the N2H2, okay? Okay, everyone. Imagine, everyone, pencils down, phones away. Just focus on this. Because on the test, not like in 2 or 3 weeks, you will be given, hey, N2H2, show me how it looks like. Okay, so let's actually look at it. N2H2. Okay, what kind of elements do I have here? What are the only kinds of elements I have here? What are they? No. Not how many full atoms. How many elements do I have? 2. Nitrogen and, okay, let's sketch nitrogen. Here's nitrogen. What's the deal with nitrogen? Does anyone remember the atomic number for nitrogen?
7.
7. You can sketch all of 7 or only sketch what? The valence electrons of how many? No. Because remember, 2 and then what? How many? 5. So how many does this one have on the valence? If I want to just do the Lewis dot diagram. 1, 2. Okay. So how many do I need to sketch? There are 7, but I don't need the first 2 because they're full circle. Okay, 7. Okay. Let me sketch the other N. Where is it? Just next door, right here. How many as well? It's the same thing. So it has to have what? 5 as well. Okay, done with the nitrogens. What goes next? Hydrogens. Sure. I'm just gonna sketch. Who cares? Like maybe here. And hydrogen has how many?
1.
Just 1. Hey, what if someone says, all good? Thank you so much. What if someone says, is there an element that has no protons in it? You say that nitrogen has how many? 1 proton inside, 1 electron outside. Could there an element exist with no protons inside, like with an atomic number of 0? No. You know why? Because if you have no protons inside, you also have no what? If you have no protons inside, you also have no what? What's outside always? Protons inside. If you have no protons inside, you have no electrons outside. Which means you have what? You have no protons inside and you have no electrons outside. Which means you have what? You have nothing. If you have no protons inside, you cannot have any electrons outside, right? Because they have to match. If you have 0 inside, you also have to have what? 0. If you have 5 outs inside, you have to have what? 5. 100, 100. It has to match. So if you have 0, you have 0. But if you have 0 all over, what do you have? Thank you. So that's why you have to at least have 1 proton or 1 electron inside. That's it. Okay, so where do I put it? I put it here. Okay, where's the other H? Here as well. Okay. Now, everyone, H has how many in it? 1. No, has how many in it originally? How many? 1. Is 1 happy? What's the full number for the first circle? 2. So hydrogen just having 1 is not what? Is not happy, not enough. So how many does it need? So it needs 2 in total or 1 more. So what does that mean? This one here. Okay. Oh, not that. Sorry. What just happened? What did I do with the hydrogen? I moved it very what? So the hydrogen used to have how many? How many? No, used to. it looks like now it has how many? 2, right? Again, I'm hoping that you're seeing what I'm doing here. 1. Does that make sense? Okay. Can I do the same with this hydrogen? Are we good so far? Okay. Is that nitrogen happy? Why not? How many electrons does it have around it? Total. No. All of them. Again, just focus on this part. How many people say 6? Yeah. 2, 2, 2. 6. Is 6 enough? Not for the second circle. How many do you have on the second circle to be full? It's almost full now. It needs to be full. How many? 8. How are we going to do that? By the way, you can play with these any way you want. Should I keep this one here or move it here? What do you think? Remember, I'm trying to connect them and I'm trying to make them both happy. Any idea? Okay, everyone look. I'm going to do this. Does that help? No, not really. I mean, okay, yeah, it makes them nicer looking, but does it help the chemistry? No. But am I preparing for something? I am. I'm not done yet. I'm preparing. How about here? Does this help yet? What can I do now? That's the whole idea.
Okay.
Okay. Is the hydrogen still happy? Yeah. How many does it have near it? No. How many does it have near it? Perfect. Hydrogen wants just 2. How about this one? What about each nitrogen? One second. 8. What about the next nitrogen? Sorry. One second. How many? Are both nitrogens happy? Perfect. Now what do? Now, can you leave it like dots? You can, but we don't like to put them as dots. We like to make them what? Lines. So easy to make them lines. But you have to, okay, everyone, I did not make the rules. This is what you have to do. Everyone, look. Those 2, you can't put on top of each other. You have to put them what? You see how now it makes a line? You play with it until you see, oh, that's how you make the lines. Same thing here. Is it making sense now?
Is this two lines?
Look. Yeah, look, everyone. Sorry. Everyone, look. Here's one what?
One line.
One line. How about this one?
One line.
How about this one?
2 lines.
Okay. Check this out. Look.
2 lines. How it's here. Yeah.
That's it.
It's so easy.
It's okay. It's easy now.
Yeah.
But can you imagine them 150 years ago actually step by step trying to discover? I'm like, oh, that's why they connect this way. It took them a lot of time to try and to screw up and to not get it once, twice, 100 times until they're like, that's the only way it happens. That's right. So I know why you said it's easy. Uh, it's like a lot of playing with it's playing a game until you get it right. Make sense? Again, can we do the same thing with this one? What do you think? Can we do the same thing with this one? Yes, I have to put the SI, the H, and start what? Bringing them closer until I make each single one happy. How about the CH4? Okay, can someone tell me what's the CH or what's the C? What's C? No, C, capital C. Carbon. Can someone tell me what's the atomic number of carbon? Like how many protons does it have inside? 6. Which means how many electrons does it have outside as well? 6. But how many on the first circle? So how many on the last circle? 2 plus what gives you 6? 4. So everyone, carbon looks like this, right? How many does it have?
4.
Is it happy? Is 4 on the last circle happy? What does it need it to be? No. 4 is not happy. What is happy on the second circle? 8. So okay, Zainab, how many does it need more? 4 more. Where's it going to take them from? 4 hydrogens getting closer. You see? Same idea. Then you look, here's a hydrogen, right? And the hydrogen only how much to bring along? What about the hydrogen from here? Hydrogen here. Hydrogen there. How many? Now, far away, are the hydrogens happy? No, far away. Are the hydrogens happy? No, they're not, because they only have how many? But they need to have how many? So what do? They get closer, so they feel like they have to. So what happens? This one, where does it go? Closer. You got it, my friend. Can I make the lines now? What do you think? Can I make the lines now? Yeah, I put them very close together. So what do? I'll use this line. You have 4 lines. Is the idea sinking in now? Do you see why sharing is very important? Yeah, you don't always have to lose and gain fully. You can still get close and what? And what? Share. But you need to stay close. You break it down. Everyone, what happens if I break this down? Sorry. What happens if I break this down? Yeah, you might say, can you break this down such that this happens? Can you ever have this? Everyone look. Can you have this? Oh, sorry. Can this ever happen? Sorry. No. If that's going to go away, what is it going to take with it? It's got to take the thing it brought along. Sorry. Yeah, this never happens. No, never. You want to break it down? Sorry. You're going to have to, what? I'm sorry. I'm going to take mine with me. You see what's going on? It's sharing. When you share and you want to leave the partnership, when you want to break up, you will take your stuff with you, right? So basically, there we go. Yep. Now you might ask a question, does this thing happen in real life? Yeah. You brought them together, you can also what? You can also what? Separate or break them apart. Yes, exactly. Hey, you bring it, you take it back when you leave. All right? Yes.